All right, we are here to do a walkthrough of learning target number 7, exponential functions, practice quiz number 2. Level 1, identify the representations that are linear or exponential. Well, let's start by thinking about linear functions. How do they change? They grow by addition or subtraction. So we want to look for representations, graphs, tables, rules, contexts that change by addition or subtraction. For exponential functions, we're looking to see which ones grow by multiplication. That's the key difference here. So let's check out our tables first. How are the tables changing? Well, as x goes up by 1, I see y changes by plus 2, okay. Oh, plus 4, plus 6. Well, that's an odd trend right there. It's not adding by the same amount every time. It's not multiplying by the same amount every time. So it must be neither. Let's check b here. How is b changing? 128 to 64. Well, that's dividing by 2, dividing by 2, dividing by 2, dividing by 2. Turns out dividing by 2 is the exact same as multiplying by 1/2. So b must be exponential because it is multiplying by 1/2 every time. If I check c, how are the y values changing for c? 6.5 to 6 is minus 0.5, minus 0.5, minus 0.5, minus 0.5. It's subtracting 0.5 every time, which means c must be linear. For the graphs, which graph is linear? The key is in the word linear. Linear means straight line. So which graph is a straight line? That's got to be D. All right. An exponential graph has the hockey stick curve. It doesn't get flat anywhere. So that must be F. There's our curve. Let's look at our rules. For our linear equation, we want to look for something like y equals mx plus b. Where does it start? How does it grow? I see, where does it start? -6. It grows by 1/2. The slope is 1/2. So our linear equation is h. Now notice there are no exponents in a linear equation. No exponents at all. This one has an x squared, and this one has x as the exponent. Which one's exponential? Where x is the exponent is exponential. So G is exponential. Lastly, we've got our two contexts. You have $200 and your money increases by 3% each year, or you have $200 and you earn $10 per day. Well, in this one, if I earn $10 today, then I have 200, then I'm going to have 210, then I'm going to have 220, then 230. How are we changing here? We're adding 10 every time. If we're adding 10 every time, that must mean it's linear. If I increase by 3% every time, that means it is like compound interest. It is exponential, J. So make sure you write the letters clearly over here, and don't forget about these two. I might start here if I were you. Let's go on to level 2. In this one, we are trying to create a table and a graph from an exponential function. Now remember your rule. Y equals A times B to the X. Now A here is your initial value. The number in front is your initial value. So when X is 0, it means Y is 1.5. That's your A value. Your B value tells you how you're going to multiply it. Times 2. 1.5 times 2 is 3. Right? Your B value is your multiplier, how you're going to multiply it every time. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. We're going to plot our points. We're going to plot whatever fits. So let's start at 0. So I start at 0, go up 1, 1.5. Check your scale. My next point is 1, 3. So I go to 1 on the X and 1, 2, 3 on the Y. 2, 6, 2 on the X, 6 on the Y. 3, 12, 3 on the X, 12 on the Y. 4, 24 doesn't fit, so I don't graph it. So I'm going to graph this part right here. Connect the dots. There's that exponential growth curve we're looking for. We could recognize exponential growth because our B value of 2 is greater than 1. So it's going to be this growth curve. Now, does the graph stop here? No, it keeps going in the other direction. Well, what's x -1? Continue the pattern, 0.75. So we go right there, and we can continue the pattern out this way. Does your graph ever cross the line y equals 0 right here? No, it does not. This right here is the asymptote. There is an asymptote at y equals 0. There's an asymptote at y equals 0. That means the graph approaches that line, but never actually touches it. That's it for level 2. Let's look at level 3 and level 4. For level 3, we need to, from each of these, identify the starting value, the multiplier, and the rule. Again, what I might write down at the top of my quiz is our general form here. Y equals b to the x power. A is your initial value, b is your multiplier. So what's our starting value? Here, 80,000 fish in a lake are exposed to pollution. The population declines by 22% every month. So my starting value, I'm starting with 80,000 fish. My multiplier, now be careful here. It declines by 22%. As soon as I see 22%, decline means minus. So I'm going to decline by 22%. From what? From 100. So 100 minus 22 equals 78%. Divide that by 100. So my multiplier is 0.78. Again, because it's declining, I take it away from 100. That means my rule in this case is y equals my starting value, my A value of 80,000, times my multiplier, 0.78, to the x power. Great. Let's look at number 2. My starting value is when x is 0. So that's right here. This is my starting value. So my starting value is 500. Now, what's my multiplier here? Well, it's hard to tell. 500 times what equals 375? When I'm not sure how to find the multiplier, the best thing I can do is to undo it. So how do I go from here to here? To figure it out, let's go backwards. What is 375 divided by 500? Turns out that equals 0.75. So 500 times 0.75 equals 375. It's a little bit paradoxical. Sounds a little bit counterintuitive. To find your multiplier, divide the later term by the earlier one. So finally, our rule here is y equals 500. I'll put my multiplier in green, times 0.75 to the x power. All right, let's look at our graph. First step, find the starting value. The starting value is the same as your y-intercept. Where's my y-intercept? It's right there. So my starting value is 1. How is it growing? Well, I could make a table here. I could say that I have x, when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. Now, how are my x values changing? That's a y. They're multiplying by 2 every time. So my multiplier must be 2. So my rule here, y equals 1 times 2 to the x power. Now it's okay if, because we don't need the 1 there, if you just write y equals 2 to the x. We don't need the 1 there. Anything times 1 is itself. Both of those answers are fine. Finally, the last one, starting with the actual rule, what's our starting value? We start with 4. Our multiplier here is 5. Now for the context here, you can write anything. You can be creative. You can write anything you want. The key points that you need to hit are that we start with 4 of something. So we could say we start with 4, maybe astronauts who return with a terrible space virus. Again, the key part is that you say you start with 4. Then from there, each infects 5 people. There's our multiplier. We start with 4, and they each infect 5. That means there'll be 20 new infections, 4 times 5. Each infects 5 people, who then infect 5 people, and so on. That would be a situation that could be modeled by 4 times 5 to the x power. All right, let's go on to level 4. Last one. You start with 400 pennies in a cup. They're all fair coins with a 50% chance of coming up either heads or tails. In the penny lab, you pour them out, eliminate the tails, put the heads back in the cup, and repeat the process. Write an equation that relates the number of trials and the number of heads you expect to remain. Let x be the number of trials and y be the number of heads. Same thing we've been doing. This is the key. So somehow we have y equals a times b to the x power. Now x is the number of trials, and we're going to have y, the number of heads. A is our initial value. So how many pennies are we starting with? It says you start with 400. Now, our multiplier. The multiplier basically is asking us, well, how many are left that are going to be heads? What percent of heads do we expect? 50% chance. So that means we're going to take out 50%. So our multiplier is 0.5. So our model, our equation is 400 times 0.5 to the x. Now, how many trials would you expect it would take to eliminate all the pennies? Create a table of values to support your answer. So here, if I wanted to make a table of values, let's think about where we would start. X and Y. Well, at 0 trials, how many are there? There are 400. Then what happens from there? I flip it once. I expect to see about half our heads, and I keep them. Then half. Then half. Half. Now it gets tricky. I start getting into decimals. 25 divided by 2 is 12.5. So what should I do there? Well, I'm going to choose to round down because you can't have half a penny. So I'm going to say there are going to be 12 pennies. So after 6 tries, we should have around 6, 7 tries, 3, 8 trials, about 1.5. So we'll say there's 1 penny left. Well, after 9 trials, there's a 50-50 chance this last penny comes up heads or comes up tails. So I would say here, either 9 or 10 trials, because we expect to see less than 1 penny. Okay. If we take it away, we're down to half. Theoretically, half, 50-50 chance, could be heads, could be tails. Do it twice, unlikely it's going to come up heads twice in a row. Okay. So, either 9 or 10 trials. That is LT number 7 for level 4. Also be prepared with compound versus simple interest. Look at practice quiz number 1 for an example of that. Hope this helps. Good luck.